Hey everyone, how you doing? Good to be here today. Good to have you all. Hi Tina, good to see you here. Hi Bikers and Kevin and Marcella and Namiji. I hope I pronounced that correctly. Hi Davinda, good to have you all here. Hey Luki, good to see you. Thank you all for joining us today. In a short while, our moderator for today will be joining us here, as well as our speaker. Welcome, Yip. Good to have you here. So, Yip, your co-host now. Hey, yeah, good. So Yip, you have the floor now. Uh,
Ah, thank you, Doris. Hey, can we make Doris a co-host, please, so
yeah,
that she
sure.
can speak?
Just a moment. Doris, good to see you here. Hi.
Okay,
Great.
let me
That's
introduce our speaker, and then let's get started, right?
yeah, sure.
Okay, well, welcome everybody to Unit Masters. We're in week 3 now out of our 6 weeks program. So this means 50% through the course. Yay. Congratulations to everyone who is still part of it, because today, in the 3rd week, we get to the meat of the underlying technology. So I have like a really, I don't know, I feel it's quite an honor to have our next guest speaker with us. It's Doris Hernandez, and Doris is a governor at her DAO. Like, this is a women-led, like women devs focused developer DAO. And Doris is a serial entrepreneur. She actually created one of the top 3 e-commerce platforms in Honduras, in Central America. And Doris is a software engineer by training and a project manager, or actually a CEO of many different DeFi initiatives from Stanford University. She has built apps with more than hundreds of thousands of active users, and she's a co-founder of Dippi, which is an infrastructure startup in the DeFi space that builds enterprise-ready APIs and does so in a very secure way. And most of you have already known, and we've talked about this, that cybersecurity, for example, is like kind of a really big risk in the blockchain space. And for today's session, week 3 of Unit Masters, we're speaking about consensus mechanisms in general, right? In this kind of world that we in week 1 have learned about, that is decentralized, that uses internet to create internet of value in a world with tokens, blockchains, and cryptocurrency. And last week, Xenia gave us an overview about how to think stakeholder economies, who are the different actors in the ecosystem. And today, we're looking into the nuts and bolts of this technology and how can different parties and stakeholders come to a consensus in a world without intermediary. And Doris is the one who can explain a lot of very difficult things in an easy to understand manner for you guys. So we will listen to her share her founder story and also share the relevance of the innovation that that technology brought to us. And then we open up for Q&A. Welcome, everyone. Glad to have you with us. And Doris, thank you so much for being with us. And also share what's happening at DEF CON Bogota. She's the largest
Yeah,
conference for blockchain in Latin America is happening at the moment.
thank you. Thank you very much. And thank you guys for making time to, host this. Yeah, I'm actually in DEF CON right now. So it's just crazy the amount of people that are coming, and it's just showcasing how good the ecosystem is evolving. There are between, I don't want to say a number, between 5K and 10K people. Like, the conference is huge, the place is huge. And DEF CON is actually a worldwide conference. So usually it's like it has in London, in Tokyo, right now it's in Latin America. So it has been great. And a lot of the things that people are talking about is like consensus mechanism and how we can replicate this not only for blockchain, but as well like IRL things, right? So with no further ado, let me start the presentation right now. All right. Okay.
Do you need any rates?
Nope. There you go. Can you see my screen?
Let's go. Yes.
Great. So
you can
let's
go full
get started.
screen. Yeah.
Yeah.
Perfect.
Awesome. So again, so the question, the topic for today is going to be how to come to a consensus in a decentralized world. So who am I? Like Yip explained to you, I'm a developer, hardcore developer, love to hack. And consensus actually is a cryptographic solution. Our solution in our company, I'm co-founder of Dippi, involves as well a lot of cryptographic solutions. So we have a very solid understanding of what's going on here. So first, we need to define what decentralized is. And it refers to like a set of principles and techniques that allows you in a place that I don't know you and you don't know me to have agreement, right? And it sounds kind of complex. How can we agree if we don't know each other? Which is the solely problem that consensus mechanisms is trying to solve, right? And if you think about it in your daily life, you make centralized consensus, right? So if you want to go to eat with your friends, you'll ask like, where do you want to eat? And you'll say, hey, let's eat pizza. No, let's eat sushi. And eventually you'll get consensus and you'll go to a place. But this happens because you know your friend and you know you want to be with that person, but you trust that person with whatever decision you end up. So that is pretty easy. The challenge is how to get consensus when you know someone else, because how do I trust that what you're telling me is, you know, it's not in a malicious way. So defining the future of the system built upon decentralized consensus is like the ability for many parties to safely store and share information, but like I was mentioning, without having to rely on a centralized authority, right? And why you don't want to rely on a centralized authority? Well, because you might not have access to that centralized authority, depending on the context of what's happening. So the challenge, like I was mentioning before, is like, how can we have agreements with like adversarial conditions where the messages may be unknowingly lost and the participants behave dishonestly for their own gain? How can, and this was a challenge presented in 1982. It's called the Byzantine Generals problem, right? So I'm just going to read it for you. And this is like the underlying issue, the problem of consensus mechanism, right? So imagine a group of generals in the Byzantine army camped with troops around an enemy city, right? So they're communicating only by messenger. The general must agree upon a common battle plan, right? Whether to attack or retreat. Either way, they must arrive at agreement and act in unison, since an attack with only a portion of the troops will be disastrous. However, one or more of the generals may be traitors who will try to confuse the others. The problem is to find an algorithm to ensure that the loyal generals will reach agreement, right? So this is the problem that was laid out in 1982. How can we solve this problem? If you think about it, it sounds challenging. Like, if you ask me, I would say like it's going to be very hard, right, to get agreement to parties that we don't know. And this problem was tried to solve for like 30 years until the entire landscape changed when Satoshi Nakamoto brilliantly completed a decentralized consensus possible. And this is what really Bitcoin, brought to the table, like completely changed the game. So we have this problem from 1982, where it's just like, how can we get into agreement when we don't know the parties involved in this? And then someone, comes and brings this consensus mechanism that we're allowed to have like a distributed ledger, and we're able to consensus the transactions going into that ledger, right? I mean, as a developer, I think this is completely brilliant because this is what Bitcoin brought into the table, which is blockchain technology, which depends on consensus mechanisms in order to keep growing that ledger, right? So this is why, Bitcoin, it's such a like changing technology, and why blockchain is a changing technology, because how we're able to find a solution for this consensus mechanism. So what the Nakamoto consensus brought to the table was peer-to-peer network, and then brought into blockchain or cryptographically secure database, and proof of work, which is the requirements to add new information to this new kind of database, right? So we've been talking about these consensus mechanisms, but then there are two major ones that you probably heard in the course before, which is proof of work, which is used by Bitcoin and Ethereum, and then proof of stake, which is used by Ethereum 2, Cardano, Tezos, Celo, and basically all the new blockchains are using proof of stake, right? So first of all, what is proof of work? So imagine this, right? First, a blockchain, it's a database. Like every time you make a transaction in the internet, you have to save that information somewhere, right? So usually that is saved in a database like MySQL or Firebase or non-SQL databases, right? So what this means is that you're saving that information that a company, let's say Facebook, Zoom, Google, can retrieve for you to have access to whatever service you're using, right? But when you have a decentralized database, in this case, blockchain, since we're trying to save real information into that blockchain, we need to have consensus whether that information is true or not, okay? So in order to do that, there's proof of work consensus. So in order to gain the right to update the next block of transactions, you need to provide like the proof to a challenge that is hard to solve, that is very easy to verify. So how can I explain this in like simple words, right? So imagine you're trying to come into your house and you need to put the lock of your combination, right? So in simple terms, someone that doesn't know, let's say that nobody knows a lock, right? So you'll be trying multiple combinations until you unlock the right one. So you did the puzzle, right? Which is very hard to do. And then verifying that it's the right puzzle is just opening the lock, right? So literally that's how blockchain works. So the more transactions, the more transactions proof of work has, the harder it is to unlock this puzzle, right? So these are many people competing at the same time, trying to unlock this puzzle, right? And whoever's unlocked these puzzles gets a bit of reward from the token, in this case, Bitcoin, right? So there's a lot of criticism about proof of work. Why? Because this is, we call them like a very intense computing power in order to solve these complex puzzles, right? Because you need to try all the multiple iterations of like the correct password in order to unlock the next block, right? So it is good because it's very hard to break. It's basically impossible to break. Why? Because in order to break a new transaction, you'll have to break all the past transactions. So it's basically impossible to do. But again, in order to make a new transaction, there's high computing power, right? So like everything, there's like good stuff and bad stuff. And this is what proof of work brings into the table. Bitcoin is completely working on that. And then now we have proof of stake, which it doesn't involve miners, right? So miners are the ones that are using proof of stake and validating the nodes. And in proof of stake, you use validators, right? So in order to become a validator, you need to stake a certain amount of coins. The more coins you stake, the higher chances to be randomly chosen as a validator. So if you're chosen as a validator and you want to make like a fake transaction into the blockchain, your stake will be taken away. So how does it work? Imagine that I'm staking 32 ETH, which is what Ethereum requires you to be a validator. If I decide to, for some reason, foolproof a transaction, the network will take away my 32 ETH in order to validate transactions, right? So this is the minimum amount, but in reality, you need way much more in order to be considered a validator. So you don't want to lose the stake that you're doing in the network, right? So this is good and bad, because since the validators are chosen by the amount of money that they're staking, you have an unfair advantage of someone can put in a lot of money to be a validator, right? So this is like where the criticism in proof of stake comes into play. And I don't probably you've heard about this after the merge that just happened like almost a month ago. It's just like if you're changing to proof of stake, you're giving more power to someone that has more, can acquire more money, more ETH. Therefore, not making a decentralized network, because it will be centralized to the validators that have more ETH, in this case, more money, right? So defeats the purpose. So this is where like the Nakamoto coefficient comes into play. What is this exactly? This measures decentralizations and represents like the minimum number of nodes required to disrupt the blockchain network. So this is very important, and I talk about this when you're talking about proof of stake. It is, yes, for example, Ethereum has a very like the coefficient is great because it has a lot of nodes deployed. Yet smaller blockchains have less nodes, therefore making them more centralized, right? So it's always important to check like how decentralized is the network, regardless of what consensus mechanism they're using, because the more nodes deployed, the more decentralized will be, the more consensus you will have, and the more transparent the network will be, right? So everything ties back into how many people are using the network, right? So what are the conclusions about this quite complex topic? It's like, right now, believe it or not, it's I call it like we're like in the underlying foundations of new technologies coming, similar to when people were building the internet. It's very complex infrastructure of how it works. Yet it's important to understand how this could be applied to real world solutions, right? So the consensus theory and practice and applications are going to be driving new ways to use this kind of decentralized databases. And I'm super excited to see what's world's going to be in 10 years and probably 5. And I just can see that right now in DevCon. So hopefully you guys have like a better overview of like the consensus mechanisms. And if you have questions, I'm more than happy to answer you.
Thank you so much, Doris. Like promised to everyone, Doris is the person that helps you calm down and understand super difficult things in a way all of us can understand it. So as always, for the questions, please use the chat or raise your hand, and Doris and I will give the answers to that. And in the meantime, while we're waiting for students to put their questions into the chat, share a little bit about your current project, Dippi, because next week we're going to hear Bill Laboon from Web3 Foundation. He's going to speak about DeFi Lego blocks. But I think it's good already to today talk a little bit about DeFi, so next week we don't start from completely from scratch.
Sure. Yeah, and thank you. So you can definitely follow us in DPXYZ, and here's my Twitter, Doris HERNZ. So what we do in DP, it's like Yip was mentioning, we are in a decentralized network, right? Which is the blockchain technology. Yet you have a single point of failure, which is your private keys, right? Everyone is like taking care of your private keys because nobody wants to lose your digital assets, right? So this is a major problem in a decentralized ecosystem. Like everything has with pros and cons, and this is one of the cons, which is if you lose your private keys, you lose access to your assets, and really no one can help you. Like it's impossible, right? So our question was like, how can we retrieve private keys without relying in a centralized in a centralized solution. When we mean centralized is like using a server like AWS or KMS solution. It's more of like, if we cease to exist, our users will be able to retrieve their keys, right? So what we did is two things, is that we take your keys, we shard them. Shard them means that you break them in very small pieces, and then we put that in decentralized storage. And how it works is that you will have to add 2 more wallets to send money to your initial wallet. And what we do is that we check the changes of the blockchain, and we're able to reform your keys using zero knowledge proof, right? So this is all made using smart contracts and blockchain. So again, it's a completely decentralized solution, and we do have our white paper ready. So this is what we're solving, and it's pretty exciting to be in this industry right now, helping the new wave of blockchain users to have a more secure and decentralized ecosystem.
Can you share maybe a little bit about your favorite moments being a founder in Web3? And then we listen to somebody's question. Kevin has a question. Maybe Kevin, you write it, and then I'll give you the microphone too.
Yeah, I think what I like the most about Web3 is community. I think it's amazing how people are so collaborative. Like, you could be talking with someone that is trying to make similar solutions, and like, we collaborate. That's I think for me the major difference between Web2 technologies and Web3 is community. It's very heavily in community, and people are very collaborative. So that's what I enjoyed the most. Seeing people that are very passionate about trying to make a better world using technology in a way that is not selfish, like I'm going to be the one benefiting from this, but it's just like, how can we collectively benefit from it, Since like that's why people say whack me, no? Whack me, we're all going to make it. Actually, my hoodie says whack me. Yeah, that's what I love about Web3. I think that's very unique, and it's a game changer for the industry, of course.
Okay, let's hear from Kevin. Kevin, if you could quickly introduce yourself and then ask a very concise question, that's helpful.
So much. My name is Kevin, and joining from Kenya, Nairobi, to be precise. I have maybe 2 questions just for clarification. Now, what are the possibilities, or rather the possible challenges that DAOs change, the autonomous, or rather decentralized autonomous organization face, based on the mechanisms that with the consensus mechanisms of proof of work and proof of stake? And second question is
just Kevin, one question, right? Let's give a lot of students the chance to participate. So your first question is about DAOs and in which way they can participate in a decentralized way, or maybe you can rephrase again, and then Doris can give her perspective.
Okay, my question is what are the possible challenges or other weaknesses that DAOs experience as far as the proof of stake and proof of work is concerned?
Okay, so we need to distinguish that this consensus mechanism work for So consensus mechanisms apply for DAOs, and consensus mechanisms apply for blockchain. Blockchain is the database that we use in order to, for Ethereum, Bitcoin, and whatnot. So proof of work and proof of stake are algorithms that, like we mentioned before, we're going to bring that up here, are the way that we get into agreement to add a transaction into the blockchain, right? So that is how a blockchain works, but that doesn't mean that's how your DAO needs to work. I think we need to distinguish that completely. A DAO, it's a decentralized autonomous organization where they can choose their own consensus mechanism. And when we make consensus, just like how we're going to upvote for proposals of our DAO, of our organization, right? And how the DAO decides to do that, it's very unique, which is agnostic to proof of work and proof of stake, which are the underlying consensus mechanism living in a blockchain technology like Ethereum, Bitcoin, and whatnot. So this is very important to distinguish. So if you have a DAO, the question would be like, what is the best way for your members to upvote for proposals, and you can have your governance done. You could do that by NFTs. You could do that by having your token. You can do that by with SBTs, sold on tokens. So it really depends on the solution that you want to implement. But again, just to make distinction that proof of work and proof of stake are for like the databases blockchain technologies, and the DAO consensus, it's completely different. But that really depends on how big your members are, like what do you have available, and what's going to be the smart contract that you're going to deploy for your consensus in your DAO, right?
Yeah, very good question. Also, maybe to just share a perspective. Now today we learned about the architecture, the tech stack, like the tech layer of consensus. Right? That is about how do we make sure that in a decentralized world, whatever is written on the blockchain is kind of the single source of truth. And there are these mechanisms called proof of stake and proof of work, and they basically lead to the level of security of the blockchain. And what you were talking about, Kevin, is the human consensus layer. So now people like me and Doris and whoever, many of you are building on top, using that blockchain infrastructure and building their own projects on it. And inside these projects, there's different degrees of how do we come to consensus, like how do we govern the decisions that are made in our project. And that has different manifestations. And I think we can share with you in the chat later a recording of a previous speaker, Zeb, who shared a lot of different resources, how different DAOs govern their own decision making. We had a similar question in the chat, Doris. So Vikas is asking, if someone controls more than 50% of the vote, can they then influence the consensus? And if yes, does it mean that smaller networks are easier to manipulate?
100%. There's this 51% attack, which means that whoever has 51% stake in the network, it could change either all the blocks before and whatnot. And that's why we mentioned here before, this is why it's very important how decentralized the network is, right? And what the Nakamoto coefficient brings into the game. This is actually done by CTO of Coinbase, I believe, in 2017. And this is very important because, as you're mentioning, if you have control of the 51% of the network, then you are able to change the transactions within the blockchain, right? So yes, you're right. Smaller networks with less nodes deployed are more prone to be, manipulated completely. So yes, we have to be checking on like how decentralized this network is to prevent these kind of issues.
And Samuel had a follow-up question to that. He says, what information about a company would you look into before you started to stake like your assets with them? What are some good things to consider when staking, like participating in proof of stake with your digital assets?
Well, one is definitely, again, decentralization. That is very important, right? Because you want to make sure that it's a fair environment. Two, it really depends on your risk level, to be honest. It's just like, what's the TVL of that blockchain? How big is the community? I'm actually been working on a very big paper on like different blockchains there are and what are they bringing to the table. And the thing that makes a really good blockchain, besides the innovative like technological part, is how big the community is, right? And the bigger the community, the more decentralized will be, therefore the more reliable will be. So it's always connected with community, as you can see. So that's what I would check. And how you check how big the community is very easy to see. Probably they'll have either conferences going on or like a lot of information online, community like either Discord or a lot of information online, you see that you have answers to almost all your questions because someone else already have it. That means that there are a lot of active people in that blockchain, right? Or they're like bringing something into the table in terms of technologically innovation. But again, it will be ideal that they have a big community before anything else.
Thank you. Dorina, would you want to introduce yourself and then ask your question?
Yes, thank you so much for your very compact and very cool presentation, Doris. Thanks. And I'm curious because I have heard from a lot of friends like the narrative on that only tech teams can be successful in Web3, and they also only invest in tech teams. And I actually was curious in how the split between tech and non-tech people was in the ideation and in the brain, in the brain phase behind your company, or behind your companies, because you had multiple ones.
You just to rephrase, so your question will be like, how was the ideation process for our company?
More like in terms of all the brains and all the leading people behind the companies you're involved in. How's the split between tech and non-tech people?
So this is definitely not the first company that I've built. So it's always important to have a technical co-founder. I mean, I'm technical myself. But it's always important to have, it will be the ideal solution. It's not the only way. I think that we cannot generalize everything, right? But it will be ideal. So again, I think our part right now, we're just 100% technical team, given the fact that our solution is quite complex. But in other companies that I've had, it's usually at the beginning, it's 50-50, right? Because you can have a great solution, but then again, someone has to showcase the world how good your solution is and bring customers and investors into the play, right? So again, like I was mentioning right now in our company, we're just a technical team because we're building the solution as we speak. And for other companies that I've built before, let me see. Yeah, my co-founder was a lawyer and I was technical. And then the rest of the team was, I'll say almost 50-50, right? So we have customer people, we have the tech team. So yeah, it should be very 50-50, ideally, right? Depending on what you're solving.
Cool, thanks.
Thank you for asking the question, Dorina. Eve is asking, hey Doris, what or who are the individuals trying to solve these puzzles in proof of work or proof of stakes? Are these employees of companies? Are they coders, average Joes or Janes? Who how can we imagine a validator or a miner?
Yeah, excellent question. And that is part of the peer-to-peer. I think it's here. Yeah, so if you see this, the consensus that proof of work brings is a peer-to-peer network architecture. That means that anyone can have access to be a miner, right? And then this is not someone remember that Bitcoin is completely decentralized. That means that nobody's in charge of it, right? It's just a lot of people that use this network that are in charge of it, right? So it sounds kind of abstract, but imagine that there are a lot of people just involved using this technology. And because there's so many people involved, similar to the internet, to be honest, we are able to make these transactions, right? So nobody's in charge of validating, you do it on your own. So this is very important to understand that. And then how does it work? The mining is just, again, like we were mentioning, the miners get incentivized. Why will you want to be a miner in a proof of work environment? Because if you're able to solve this puzzle that you need, this is a cryptographic, right? So you're trying to solve a puzzle, let's say that you're trying to, again, put in the password of an email, right? Just for example, then you try to iterate, what is the password for this email so I can enter the email, right? So you start trying password number 1, password number 2, password number, and once you figure out this password, then the network pays you for this effort that you did, right? So you're incentivized to keep unlocking passwords. In this case, unlocking means that in a proof of work, what you're unlocking is making sure that the new block that is going to be added into the blockchain, it's actually a valid block, right? So when that happens, the network rewards you with a little bit of Bitcoin, and that's what people keep doing this, right? Eventually, there will not be miners. We didn't mention that, but yeah. So there are only 21 million Bitcoins in the world. I think we're like in 19 million. So the algorithm gets exponentially harder and harder and harder and harder to solve as more people are in the network. Why? Because everyone's competing. So the more people competing, the more computing power you need. So I hopefully I answered your question, but yeah, nobody's involved. It's pure math and it's beautiful essence. So that's why it's tamper proof as well. Yeah.
I think Eve is like very keen on becoming a miner. They are asking, how does one become a miner and solve puzzles?
So again, it's just you'll have to set up your own nodes, so to speak, right? So if you were doing proof of stake, it's way much easier because you only have to stake 32 ETH. So there's an amount that you need to invest, and then, well, this is the minimum amount. But again, as you know how the system is, the more ETH you have stake, the more money you need to put into chip into, right? So it's becoming like more and more expensive. Like you could have your 32 ETH as a validator, but probably you will never be chosen because there's too many validators, right?
Yeah.
So
what's happening? Yeah.
Yeah. So basically, it's just like there are services like Anchor, I believe. Anchor.
Yeah. So there's a lot of different ways. Just guys, you can do research. So now that you know that it's possible to participate in the security mechanism and in the decentralization of blockchains, of different blockchains, you can do the research on how to participate in proof of stake and how to participate in proof of work and become a miner. Because unit masters like our sessions are here to give you a glimpse and navigate, empower you to get into the position to do your research online, because you heard now all the different terminology. We have one more question from Mamta, and then we close the session for today. So Doris can go back to DEF CON Bogota. Mamta, do you want to speak?
Hear me?
Yes,
Hello.
we hear you. Wonderful.
Thank you. So my question is there an audit available for DAO? Like there has been various reg pools as such, but before I jumped into blockchain, digging into the knowledge on my own, I stumbled upon few organizations who are especially into auditing. And given what happened with the DAO, the scamming, the hacking thing, and today what happened with the Mango protocols, I don't know if there is a standard audit available for a DAO or not, or is there it's a opportunity available?
So your question is, how are DAOs audited, right?
Yes.
And I guess this again, and Doris can elaborate, depends on the system, the architecture. On the code level, there's different ways you can audit code, and Doris knows like probably the main kind of providers of code auditing in the space.
Yeah. So
yeah, so it's an opportunity space basically, but then we need like how SEC is now chipping in, and now they have asked Yuga Labs to come up with give the proof of their NFT, what values they are holding. So at the same time, the question is, the second, are there any levels of DAO that is still not there? Like we have Sigma quality of an organization, it is level 1, level 2, level 3, that sort of thing. Is it there yet? No.
Thank you. Yeah, like in auditing, there are already a few established organizations that do auditing of code, so that it's like the code, the smart contracts, for example, that are built don't have flaws, right? And right now there are initiatives to basically make standards for different ways of developing code. We are still in a phase of the ecosystem that is very, very early. So every blockchain is still kind of in the building, in the very basic building phase. We are not yet at the level of having very refined Six Sigma level kind of quality control yet. However, as we are speaking, a lot of providers are developing these kinds of standards and so on, and you can probably still participate and shape the future of quality management and security management in blockchain. If you start now, it's still an evolving field. Doris, or what do you think?
Yeah, no, I totally agree. I mean, like you have a lot of questions that are good answered. Like doesn't really have like we're still in the makings of a lot of things. Like what happened to the Yuga Labs thing is because the government's still figuring out a lot of the things, like how can we regulate this, or what happened to Tornado Cash, right? I don't know if I'm realized with it, but basically there's an issue of privacy going on there. And the thing is that governments are still learning how to manage this, because the concept of decentralization, it's completely new, and it's hard to regulate because it's a spread across all of us. And I think that as we see the industry goes, like there's going to be like great collaborations with governments and enterprises to bring things to like business cases, right? And implementing Sigma and whatnot eventually will be probably in the roadmap, like you've mentioned.
All right. Thank you so much, everyone. And thank you so much to our speaker today, Doris. Like, you can follow her on Twitter if you want to tweet about your learnings from today, tag Doris. And I hope everyone enjoyed their learnings. We will also make available the minting of your certificates very soon. So it will take another few days, maybe next week, hopefully, fingers crossed. And then all of you who have weekly filled out the key takeaway surveys will be rewarded with your on-chain certificates. So thank you very much, everyone. Thank you, Doris. See you again tomorrow
thank you.
for our workshop.
Bye-bye.